Welcome to the second episode of the series, and in this video, as you can probably tell by the title, we'll be finishing up the player, and we'll actually get into the player script. And just a quick disclaimer, this is probably going to be kind of confusing to understand if you just started Godot or programming in general, but hopefully I could, make it easier. And I assure you the rest of the series won't kind of match that difficulty, hopefully, or I'll try to, I don't know, make it easier. Anyways, you can see we're in the player scene right now. We have all our nodes. Everything is still the same. So if you missed the last episode or you want to recap, we created this simple map, or this floor, I'd say. And I forgot, we're also going to go over collisions this video. So that'll be kind of like two birds with one stone while creating the player. So let's just get started. So the first step is we want to click on our root node. And I'm actually just going to rename this to player. Control S to save. And you'll see this button at the top. It says attach a new or existing script. That's what we want. So we're going to click that, and you'll notice that there's actually a template. You can choose it if you really want to, but I'm just going to click default, and we're going to double check that our script is in the right path. To do that, we'll click on this little folder icon, and we'll go out, press this up button, and yeah, we want to be in the player folder, so this will do. You can name your script whatever you want as long as everything is green down here, but I'm going to name it player, and I'll press create. Alright, so let's go over some quick Godot scripting things. At the top, you can see extends character body 3D. This is like, you can think of it as a class. And it just lets this script inherit certain methods and properties that it can access. And if you have a script on a node, you need the node type and the class over here to match, or I believe it won't work. And as you can tell by the comments, function ready is called when the node enters the scene tree for the first time. You can also think of it as when you press the play button or when the game is launched. And then the process function, this is called every frame. If you don't know what functions are, then they're basically, you could, I guess, go with saying it's a kind of a group of code, lines of code that you could call whenever you want, and you could pass in parameters. Again, I'm kind of expecting you to have at least a little programming knowledge before coming into this, but if you don't, it should be fine. Anyways, I'm going to delete all of these, and I'll paste in the code, and I'll go over every line in detail. Okay, yeah, it looks like a lot, but trust me, it's fairly simple. Okay, so this entire section, you'll notice they're all variables. If you don't know what a variable is, it's basically a way to store data, or a single, I guess, value. And anything with a var at the beginning, and then you declare the name of the variable, and you have an equal sign, and you put the value in, and that's a normal variable. And you'll notice that there's a colon here, and the colon just it just sets like the data type to this variable. So you can see, wait, let me just give an example. Test. So yeah, it says expected initializer after constant name. And yeah, these colons help determine what the initializer is. So it basically, if you put a colon in front of an equal signs, it will set the initializer or data type as the value. So this is a float. That means the data type of this mouse sense variable will be a float. And a float is just a decimal. And this, if you want to take a guess, this would be an integer. This would set the data type as an integer. So we have a couple variables. The mouse sense obviously determines the mouse sense multiplier. The gravity determines the gravity, pretty straightforward. The speed will set, it's set to the default speed, but I just set it to 20. Doesn't matter what you set this to because it'll be set in function ready. And then we have a constant, and a constant is basically a variable that you cannot change in the script, and it has to also meet the initializer requirement. So it's useful if you don't want anything changing the variable. And a common practice is to type the variable name in all caps for a constant. And these variables, these two variables here are, they're kind of like camera settings. They're kind of extra if you really want that extra touch with your camera movement. I included that, and it would also be useful if later on when we implement like guns in Bloom, that would also be fairly simple to, or a extra, I guess, step. And then we have the Y speed, and I'll go over exactly what that is. We have the jump strength, we have the jump number, and we have a max jump amount. And I'll go over exactly what these four mean in detail later. And the sprint speed is just how much speed we add on to speed when we sprint. Okay, and you'll notice there's another type of variables, and these are called, or they have an annotation of @ on ready, and basically this will be set when the same time this is called, the function ready. So when you press play, it'll be set then, and that's because we want to get a reference of a node with these variables. If you want like an easy way to get these variables, you left click on a node, right? And you hold left click and then press Control, and you can drag that into your script, and it'll automatically create an onReady variable for you. Okay, so we created the neck and camera last time, and you'll see how they're going to be used in a second. Okay, so in function ready, we went over that. It's basically when the game starts, and we want to set our mouse mode to a mode where we can't see it. So because we're doing an FPS, right? We don't want our mouse to be on the screen. So it's going to be in the middle. Our mouse is going to be locked in the middle, and it's going to be invisible. And just a quick tip, if you're confused about what a certain thing does in our code, all the inbuilt properties and methods and resources, they all have inbuilt documentation within the editor, which is a really neat feature in Godot. So you can press Control and click on anything you're confused about. So if I'm confused about set mouse mode, it'll bring me to this page of documentation, and I can see that this controls the mouse mode, and I can click on this to see more information. So that's pretty useful. Alright. we're actually going to do another step right before we get into this function. So you want to press project settings, then input map. And this is where we can define all the keybinds to certain events. So the first default actions we want are forward to move forward. We want back, or you can do backwards. I don't really care. I'm just going to do back to move backwards. We want left to move left. We want right to move right. We also want a jump button, so jump, and we want a sprint button, so sprint. So yeah, you can add the actions by typing in this little bar and pressing add or enter. And to set the actual keybinds, you want to press this plus button, which will add an event. And then you just want to press the keybinds, or the key you want to set to the action. So I want to move forward by pressing W. So that's what I'm going to press. I'm going to press the W key on my keyboard, and it'll automatically fill it in. And you could always add multiple keybinds to these actions. So if I want to add the up arrow to move forward, I could also do that, and it'll take in whatever one of these is pressed. So I can press the up arrow to move forward, or I can press the W key to move forward. But I'm just going to delete that because I don't know why you'd ever use the arrow keys. And then we're going to use S for back, left will be A, right will be D, jump will be space, and sprint will be shift. You can change the keybinds to whatever you want, and it will not make a difference at all, as long as they're not overlapping. So as long as like sprint isn't the same as forward, something like that. Okay, let's go over what function input does. So again, you can click on this, you can control click on the input function, and basically this function is called when there's an input event. And an input event can be practically anything. Like I can press a key on my keyboard, or I can move my mouse, or I could press a mouse button. It's a lot of things, and it also includes mouse motion. So it's an inbuilt function, so that means that it has a inbuilt, or it passes in a parameter by itself, which is an initializer of an input event. And you can control click on that if you want to read more about that. But we want to see if the event is like an input event mouse motion. So we want to see if the event is us, the player, moving our mouse. And if it is, you can see that the syntax for writing an if statement is pretty simple. You just write if, and then what you want to check, and then colon, and then if you press enter, it will automatically indent. So if we are moving our mouse, we want to rotate the player on the Y direction. So you can see the Y direction is the green ring, and we'll rotate that by our mouse's X position on the screen. So if you can imagine a coordinate system on your screen, the X system, or the relative dot X, would be our mouse's X coordinates on our screen. And then we'll multiply that by our mouse sense, and we'll do the same for the X axis, which is this, looking up and down. But instead, we'll change the next X rotation, and this would get the mouse's Y position on the coordinate plane of our screen. And then we're going to clamp the rotation, so basically this method just ensures that the value we pass in will not surpass the limits we set. So we do not want our neck rotating 360 degrees. We want it to lock like probably here and there, and that's what we do with the clamp method. So we set the minimum to -50 degrees, radians, or actually we do degrees to radians, and then we set it to the max to 60. And then we'll create the function jump, and this will be called in physics process. All we gotta do for this, it's fairly simple, is just do jump number plus equals 1, and this will keep track of how many times we've jumped before touching the ground. And then we have y speed equals jump strength. So y speed, you'll understand exactly what it does later, but for future purposes, it's velocity.y, and we want to set the velocity.y equal to our jump strength, because that's how we will actually move off the ground. Alright, and then physics process, this is a lengthy function, and this is also an inbuilt function, and it has a parameter of delta. And just to clarify, the function jump is not an inbuilt function, so that's something we create ourselves. Okay, so we'll set velocity equal to get direction, which is a function we'll create in a second, and we'll do dot rotated vector 3 dot up rotation dot y times speed. So the dot rotated just basically gets the direction we want to face, and then times speed will just actually make us move forward, and get direction will check like if we press W, then we're gonna move forward, right? If we press A, we're gonna move to the left. So it kind of checks what direction we're moving in. Anyways, oh, also velocity is an inbuilt property, and properties, an example of a property are any of these on the right side. So like slide on ceiling, that's a property. But obviously you can't see velocity because it wouldn't make sense if you could change it within the editor. Anyways, we have another if statement, and we're checking if the character body is on the floor. And this is an inbuilt method. So if it is not on the floor, then we want to add a gravity to our velocity.y, which is also y speed. And otherwise, we're gonna set y speed equal to 0.0 and jump number to 0, because we want our jumps to reset once we touch the ground, because you can't jump 5 times in the air. And of course, if you want to have like 5 jumps in your game, then you can change the max jump amount to 5, and you'll be able to jump 5 times in the air before touching the ground again. Alright, so also if we are on the floor, we do not want to be flying or going into the ground, so that's why we're going to set our y speed equal to 0. Next, we'll check if we press the keybind jump, which I have to change, jump. Make sure you type in the name of what you put your keybind as. You can check in input map, so make sure it's the exact same. Alright, so we also want to check not only do we want to check if we press the jump button, but we also want to check if we can jump. And we can check that by seeing if the jump number is less than the max jump amount. If it isn't, then we won't be able to call the jump function, which we defined earlier. And yeah, and then we have, okay, well, this is not supposed to be there. Then we have our sprint kind of action. So we check if we press sprint, our sprint keybind, sorry, and if we're on the floor, we'll add sprint speed to our speed. If we're not on the floor, then we'll set our speed equal to default speed, which is our constant, so it shouldn't change. And if we're not pressing sprint, then we want to set our speed back to default speed, because if you press sprint, right, then your speed is going to be set to whatever speed plus equals sprint speed until it's changed. That kind of didn't make sense, but it's basically you just gotta set it back to the original value. And you can delete this part if you want to be able to sprint midair. I didn't really like how that sounded, so that's why I included this else statement. Oh yeah, I forgot to mention, yeah, to include an else, you just have to make sure the else is on the same indentation level as the if statement, and then you just do a colon, and then you just do what you want the code to initialize. Anyways, over here, we're gonna smooth out our camera. So we're gonna get our camera.rotation.x, which again is this part. And this is kind of like a, I don't know, a really neat kind of implementation of, I guess, you'll see, I don't know how to explain it. So the lerp method just kind of, you can think of it as it averages out a number based on a weight. So averages these two variables or in property dependent on this weight. Again, you can see what this method needs by control clicking, and you can see all the parameters that you must put in. And essentially what this does is when you press the W key, your camera will tilt a little forward. If you press the S key, your camera will tilt slightly back. Okay, and then the velocity.y equals y speed. So we set all the extra, I guess, the jumps and stuff in gravity onto y speed. So now we gotta set the velocity.y equal to y speed, and then we call move and slide. And this just it's an inbuilt thing, and it just lets us move basically. And then we have function get direction, and this is the last function we need. All we need to do is define a variable called direction, and you can see that we defined the data type as a vector3. And a vector3 is basically just coordinates in the 3D plane. And we gotta set the direction.x and z equal to whatever this is, right? And what this is it basically, if you press the keybind for going to the right, this will return 1. If you don't press right, it will turn it as 0. So you can imagine if I press right and left, it will cancel out and I won't move anywhere. If I just press the right keybind, I'll move to the right. If I press the left, then it'll be 0 minus 1, so I'll move to the left. And it basically just gets like the rough direction. So if like I'm moving to the left, it's gonna have to be on the negative side of the coordinate plane. And if I'm moving to the right, it'll have to be positive on the x direction. And we do the same thing for the z direction, which is this blue axis. And yeah, so that will get to the direction we want to move toward. And this is, you could add this if you really want to. I hated it, so I just set the, I think I actually deleted it, so I don't know if it's gonna work even if you include it, but it basically tilts your camera from like to the right if you're moving to the right, and vice versa if you're going to the left. I could not stand it, so I removed it. But if you want to include it, you just have to basically copy this line and change the rotation degrees to Y, I believe. Yeah. And obviously change that number. And we just gotta set the direction.z times 7.5, which is just like a multiplier to actually see the effect. And this variable is, again, used to tilt the camera forward and back. And then we have whatever this line of code is. It's a return. It returns basically direction.normalized. And you can see what normalized is it just converts it to a certain unit. And when we return something, or when we use a function to return something, it's really useful. So like, pretend, you can think of it like if you were doing a math equation like 3 plus 1 times 2. So you can think of, instead of adding the parentheses, we can just replace this with add numbers, right? And when the function is completed, it'll return whatever 3 plus 1 is, and then we'll just multiply that result by times 2. So basically just a way to set a variable or a condition, I guess, or yeah, I think you get the point. Yeah. Anyways, we're done with the script, but regardless, this will not work, and that's because we haven't added collisions. So a simple way to understand collisions is, you can see on our screen, we can see a mesh, right? This gives the players visual representation of where the I guess the body is, or where the floor is. But the game also has to know where these objects are, and it has to calculate physics based on where the collisions are. So to do this, we're going to press project settings. We'll go to general. We'll scroll down. You'll see layer names. You want to press 3D physics. And now we're prompted with a bunch of layers. So on the first layer, we want to do world. And the second layer, we want to do player. And that's all we'll need for right now. So we'll press close. My voice is completely dead. I'm sorry if I sound like, I don't know, weird. But anyways, so we still have this warning or error, and it says the node has no shape, so it can't collide or interact with objects. So if you don't have a collision shape, you could walk through whatever the mesh is, and or the player will just fall all the way down. Actually, I lied because it won't have a collision, so it won't fall because this won't even run. Anyways, to add a collision, we're just going to type in collision shape, and the shape property, it's similar to creating a mesh. So we're going to click the capsule option, and it automatically fits our shape. But if you have a mesh that's different, that's not an inbuilt shape, like a shape, shape 3D, then you can click this button at the top, and you can click one of these options depending on the requirements you need or your situation. But I'd recommend either Trimish collision sibling, or I just recommend that because that's going to be the most accurate. And if you have like a really complicated mesh, like you have like an actual human model, then I'd actually recommend just creating a capsule shape regardless, and just fit the general like the general hitbox of the player, so you don't have to include like a kind of a collision shape on its arms and fingers and stuff, because that would make your game like probably 10 times more laggier than it needs to. And yeah, you wouldn't need to ever calculate where if your fingers are colliding against the wall. That's just like, I don't know, bad development. Anyways, we also need to move our player to a certain collision layer, which we just created the names for. So if you click on the player, the root node, then we can go to this collision, I guess, drop down, and you'll have a layer and a mask. What the layer does is it will set the collision to basically, I guess, a simple way of understanding what it does is a layer basically gives the collision or character body 3D a name, and the mask will, if you have the mask set to worlds, right, then I'll basically look for all things with the name of worlds to collide with. So if you don't have a mask on, then you're gonna fall straight through the ground. And again, if I didn't explain that properly, basically the layer is what defines our collision shape, and the mask is what we're looking to collide with. So we also had to set our floor to a collision shape so that we don't fall straight through the ground and into the void, as you can see. Alright, so to do that, you could click create trim static body, but I'd recommend just adding a static body yourself, and then adding a collision shape, creating a box. Actually, this is a plane, I think. Yeah, it's a plane, so we'll just create a trim static body. Sorry. Okay, so that should have done everything for us, and you can see if we raise this collision shape, you can see the general shape of it. But we need to set our collision layer for the static body. So typically the floor is part of the world, so we're going to have it on the world layer so that our player can actually collide with the floor, and our mask will be set to world and player. I like having the worlds kind of like collision layers or objects detect the world and player, because if there's like a rigid body, kind of, you'll explain. Actually, that's a terrible explanation because you don't know what a rigid body is. But basically, if you have something that another world object that wants to collide with like the floor, so like if I have a can that can be like thrown around, I also want it to collide with the floor so it doesn't go straight through the floor and disappear. So that's why we have these two checked off. Alright, so the last step is to actually add our player into our scene. And to do that, we're going to press Ctrl-Shift-A, and we'll be prompted with this child scene, or instantiate child scene, and we're going to click player, the player scene. And also, you could also add a scene by clicking the button to the right of the add node button, and you'll be prompted with the same screen. Anyways, you can notice that our player is halfway through the ground, and we obviously don't want that. So a really cool trick in Godot is you can raise this as high as you want. And since we have a collision now, collision shape, Godot will recognize this as the floor. So we can click on transform and snap object to floor, and click Ctrl S to save. I'm also going to rename this to floor. And there's one last step I forgot to mention. I'll show you guys. So if I run the project, just press select current if this pops up. So if I run the project, you can see everything is really gray, and I'm getting errors because I forgot to change my input. So I did exactly what I told you not to. So let me just change that. Also, if you get like a thing that pops up, if you haven't figured that out by now, you can press tab to auto fill in. So example, you can see I can press tab to autofill right in, or I can use the down arrow and up arrow to go through, and then I can press tab. But I'm just gonna press, or you can press enter too. That works. Wait, I think I lied. I don't think you can even use tab, can you? Yeah, you can. Never mind. Yeah, okay. So to fix this problem of seeing a really dark environment, hint, we're gonna actually add an environment. So Godot saves us the trouble of actually implementing our own sun and environment. All we have to do is just click these three buttons, add sun to scene, click this button again, and add environment to the scene, and it'll work just like that. You see, I have a shadow, I can move, I can sprint. I know the sprint will launch you like crazy, so I'm not gonna really press it. And you can see that my camera is tilting back and forward, which is kind of cool. And yeah, so now you have a working character body. And hopefully in later videos we'll be able to maybe up the movement in the game, actually make a better sprinting system, because as of right now it's kind of trash, I'll be honest. And we'll make our map look better. We can do a lot of things, and I think the next episode I'll try to crank that out as fast as I can, because I know I had quite a big gap between this episode and the last. I'll try to I'll make it like a simple one to, I guess, make your game look a little better, and you can customize your game to fit the style you want. and that would be like an introduction to, I guess, making your game look better. Alright, so thanks for watching, and if you have any questions, let me know down in the comments. I think if it's not on this video, then it'll be on another video. I'll be making a Discord server, so you guys can ask me questions there too. And if you have any tutorials you'd like to see, any recommendations for this series, and then also let me know down in the comments, and I'll gladly, I'll go right at it, because it's kind of hard to plan tutorials out, so I don't really know what our community wants. Anyways, thanks for watching, and if you enjoyed this, please like and subscribe, and I'll see you on the next episode.